Sir, good evening, sir.
Good evening, Yuvraj.
சார் நேத்து பண்ண ப்ராஜெக்ட்ல வந்து அவுட்புட் வரல சார்.
ஓகே. எரர் வருதா? இல்ல அவுட்புட் எதுவும் வரலையா?
இது வந்து ஃபுல்லா ரன் ஆயிடுச்சு.
ம்.
ப்ரோக்ராம் ரன் ஆயிடுச்சு. பட் ஆனா
ம்.
நான் 5 வோல்ட் குடுத்தா அதுல வந்து டார்கெட் நாட் செலக்டட்ன்னு வருது சார்.
டார்கெட்
டீபக்
நாட்
பண்ணணும்.
ஓகே. டார்கெட் நாட் செலக்டட்னா போர்ட் கனெக்ட் ஆகலன்றது மீனிங்.
ஆனா போர்டு ஆன்ல தான் இருக்கு. டம்ப் ஆயிடுச்சு. ப்ரோக்ராம் டம்ப் ஆயிடுச்சு.
ஓகே.
ஆனா குடுத்தா வந்து இந்த இது காட்ட மாட்டேங்குது. 5 வோல்ட் அந்த வேல்யூ காட்ட மாட்டேங்குது டீபக்ல.
ஓகே. ஸ்க்ரீன் ஷேர் பண்றீங்களா?
ஆ இங்க தான் சார் ப்ரோக்ராம்.
ஓகே.
இது ஓகேங்களா?
போர்ட் கனெக்ட்
இது
பண்ணிட்டு டீபக் பண்ணுங்க. ஓகே. ரெஸ்யூம்.
டார்கெட் நாட் அவைலபிள்.
ஓகே. டார்கெட் நாட் அவைலபிள்னா அப்பனா இந்த வேரியபிள் இல்லைன்னு அர்த்தம். ப்ரோக்ராம்ல இந்த வேரியபிள் எங்க டிக்ளேர் பண்ணியிருக்கீங்க? ஏடிசி அண்டர்ஸ்கோர் வேல்யூ. ஓகே. அதை காப்பி பண்ணி அந்த வேரியபிள் மட்டும் காப்பி பண்ணுங்க. ஓகே. இதை டெர்மினேட் சரி வேணாம், அப்படியே இருக்கட்டும். ஆட் எக்ஸ்பிரஷன் வேண்டாம். அதை ரைட் கிளிக் பண்ணி டெலீட் கொடுத்துருங்க. ரிமூவ். ஓகே. மேலே லைவ் எக்ஸ்பிரஷன் ஒன்று இருக்கா? அதை கிளிக் பண்ணி ஆட் எக்ஸ்பிரஷன், பேஸ்ட், என்டர். ஓகே. வேல்யூ வருதா? ஓகே.
அப்போ இதுலதான் ப்ராப்ளம்.
எக்ஸ்பிரஷன் என்னன்னா, எக்ஸ்பிரஷன் வந்து நீங்க ரன் பண்ணும்போது உங்களுக்கு என்ன வேல்யூ இருக்கோ அந்த வேல்யூ தான் எடுத்துக்கும். அது சிங்கிள் டைம் வேல்யூ கெட்டிங். ஓகேவா? நீங்க இப்போ டீபக் மோடு உள்ள வரும்போது அதுக்கு என்ன வேல்யூ இருக்கோ அந்த வேல்யூ எடுத்துக்கும். அதுதான் வந்து எக்ஸ்பிரஷன். ஐ மீன் வெறும் எக்ஸ்பிரஷன். லைவ் எக்ஸ்பிரஷன் வந்து லைவா நீங்க வேல்யூ சேஞ்ச் பண்ண இங்க உங்களுக்கு அப்டேட் ஆயிட்டே இருக்கும்.
ஓகே.
ஓகே.
தேங்க்ஸ்.
ஓகே.
Hi, sir.
Yeah, hi, Evan.
So one doubt actually.
Mm.
So the I'm using that discovery board, right?
Yeah.
Actually, like V reference or it is maximum 3.3 voltage for this. We cannot make it. I mean, I checked in the Google and other like stuff like
Okay,
we
so
can modify it. Yeah.
okay, you have maximum 3.3 voltage only.
Yes. Yes.
Okay.
If I give
Mm,
3.3 showing 4096.
mm-hmm.
That value. But if I give 5 voltage, like
Mm.
I don't have potential meter, so I give it as 5. It is showing some random value like 3000
Yeah,
or
yeah.
something. I
It
think it's
will just make,
overflow value.
yeah,
I
overflow
guess.
value will get. Okay.
I
So for
search it. Can
mm.
we can may change it to from 3 to 5, but it's not possible. I guess Google I check.
Okay. So for you also it's 10-bit ADC only, right?
Yeah, it's a 12 bit, 12 bits.
12-bit ADC. Okay.
So three
4080.
ADC is there.
Okay.
But,
But don't you have a 5 voltage anywhere?
I have 5 voltage in the board itself.
Okay.
But for ADC, V
For
reference, we
ADC,
can use
V
only.
reference is only 3.3. Okay. Okay.
Yes,
Okay.
I have checked in the. I mean,
Okay.
Google it's showing like only 3.3 because I get 3.3 maximum value
Okay.
for
Okay.
not
Okay.
96, but
Mm-hmm.
5.2 overflow value.
Okay.
Good evening, sir. Hello.
I think your voice is not audible.
Yeah, am I audible now?
Yes, sir.
Okay, so from beginning,
Yes, sir,
my
audible.
voice is not as audible now. Okay. Okay, so you know what I did, right? I just opened this previous OKV program, okay, in that IOC file. I just configured this PS0. Okay, that's it. Like I'll just directly go to this analog ADC1, and here I just enable this IN0, input 0. Okay, so this input 0 is nothing but it is a PS0, ADC1. Okay, and here I just made this continuous conversion mode as enable. That's it. I didn't do anything. And also I made this PA5 as an output mode. I'll tell you why. This one I made this PA5 as an output. I need an LED for that. I'll just make it two LEDs. Let's say PA5 and PB1. Okay, let's make it two LEDs. So I'll just generate it again. So the code will be generated for the IOC file, which I configured. So I'm just going to copy this, and here I will exit from school screen. I will paste it in this main.c. Okay, so here you can see I have two different pins, PA5 and PB1. Okay, so now what I'm going to do is I'm just going to connect and potentiometer to this PA0 or A0. Either one of this, both is same. Either you can connect this in the ST-Morpho pin, that is PA0, or you can connect it to this Arduino pin, A0. Okay. Sorry. So I'm just going to take a new part here. I'll take an potentiometer. I'll just search it here. Potentiometer. Okay. So this is what my potentiometer is. I'm having a VCC signal and ground pin. Okay. So VCC pin is, this is my 5 volt VCC. So I'm just directly taking this VCC pin and I will connect it to the potentiometer. And this is my ground pin. I'll just take this and I'll connect it to the ground. Okay. And then I have a PA0 or A0. Both are same. I'm just taking it from the PA0 to the signal pin. Okay. So now I'm getting an input signal varying from 0 to 5 voltage. Okay. So that will come as an analog signal. This analog signal will be converted into digital by using the program. Okay. Now, for the program, I'll do the same thing. Like I'm just going to start this poll for conversion. Then I'll get the value. Then I'll just stop this one. Okay, the same thing I'm just going to do here. So where is the previous code? This one. So I'll just copy the same thing and I will paste it here. Okay. So first one, I have started the half ADC for this HADC one, because here also I'm having an HADC one as my handler for ADC. Okay. So the same thing I'm just going to use here. After this, I will start this poll for conversion. For 100 milliseconds, I'm just waiting for this conversion to be completed. Once this conversion completed, it will check whether it is an HAL OK. HAL OK means the conversion completed for the analog to digital. It will return HAL OK. Okay, so if it is HAL OK, then the conversion is completed. Right, then I will go here, I will get the value, and after that I'm just going to stop it. Now, in our hardware mode, what we did is we actually opened this debug mode, and then we use a live expression for checking the ADC value. Okay, here we don't have any debug mode in the simulator, right? So what I'm going to do, I'm just going to connect two different LEDs. Okay, so I'll be getting the value from 0 to 4096, right? 4095 actually. Okay, 0 to 5 voltage, that will be ranging from 0 to 4095. Now what I'm going to do is, if it is less than 2000, I'm going to turn on one LED. If it is greater than something like a 3000, I'm just going to turn on one LED. Okay, so that I'm going to write a program for that, right? So I have connected PA5 and PB1, right? So I'm just going to write this code here. Here I'm getting this ADC value, right? Once I get this ADC value, if my ADC underscore value, if it is greater than 3000, okay, then I'm just going to turn on, let's say GPIO B pin number 1. Okay, I'm just going to set this one. Okay, similarly, I need to reset for the other pin, right? So I'm just going to copy and paste. So for PA5, this will be reset. Okay, if it is greater than 3000. Else, if this ADC value is less than 2000, 2000, 3000 is a ranging value. Okay, so I'm just going to paste this as it is. Okay, this I'm going to reset, and this I'm going to set. Okay, or else if both the values are not present, then reset both the values. That is, in the range of 2000 to 3000, both this LED will be off. Okay, so from 0 to 2000, one LED will turn on. Okay, and 2000, 3000, both the LEDs will be off, and from 3000, one LED will be off. Okay, so we will just maintain, let's assume we are maintaining the range from 2000 to 3000. If it is greater, that means it is an over or it is crossing the threshold value. So you are just giving some warning signal. Or if it is less than some threshold value, you are just giving another threshold value signal. Okay, so that is what this program is for. Is this part clear? Do I need to explain it again? This if
Sir, line number 116.
line number 116. Okay, line number 116 is for
ADC underscore value.
sorry, it's a ADC underscore value. Okay. Yeah. Okay, is it clear? Any doubts in this?
Sir, line number 131. Unwanted line.
This is not needed actually. Okay. Okay. Anything else?
Sir,
Okay. Yeah.
3000, 2000 delay time, sir.
Delay
If
time
the
ADC
condition.
ADC value. ADC value.
Okay.
ADC value நம்ம நேத்து
Okay,
பார்த்தோம் இல்லையா? You'll be getting from 0 to 4095.
Yes, sir.
So this is for the ADC
Okay.
value.
Okay. Okay.
Yeah. Okay. So now I need to do this connection for the LED. So I'll just take two different LEDs. One LED, one resistor. Okay, so I need to connect it to the PFI, right? So PFI is over here. So I'm just going to flip this with the resistor connected to the anode and it is connected to PFI. Okay, so this will be connected to ground. Okay, this is one done. And the next one is PB1. This is PB1, right? Okay. So I'm just going to take one more LED with a different color. I'm just going to flip this with a resistor. Add it to PB1. Is it PB0 or PB1? Okay, let's check. And for the ground pin, do we have any other ground over here? We have an analog ground. Okay, we will just connect it same place.
ஒரு LED வந்து
Saronan, your mic is turned on. Okay. So if it is greater than, I'm just setting PB1, right? So I'll just make that as a red color. And this one, I'm just going to make it as something like green color or blue color. Okay. So this is what my circuit is. One is the potentiometer. So based on this potentiometer reading, one LED has to be turned on for a particular amount and another LED has to be turned on for the another particular amount. So I'm just starting the simulation. Let's see whether it is working. Okay, so I'm getting an okay, ADC value I didn't declare anywhere. So that I did in the previous value, right? So ADC val here in this private variable, I need to declare it as an unsigned integer 32 underscore t ADC value. Okay, yeah. I'll just do this. Okay, so you can see here my blue color LED, that is PFI, is turned on. So it will turn on until it is 2000 value. Okay, so I'll just move this over here So once it reaches 2000, it has to turn off. Okay, off a stage. Be a 0. What is the issue?
Sir, red LED pin number check பண்ணு.
Anyhow, this LED has to turn off, right? After 2000. Here I just given as a reset. So this LED has to be turned off.
Sir, initial condition கொடுக்கணும்ல சார் வச்சுக்கோம். at 0ல ரெண்டுமே glow ஆகணுமா இல்ல ஆஃப்ல இருக்குமா?
அது ரெண்டுமே ஆஃப்னு சொல்லிட்டேனே. though else condition. That is from 2000 to 3000, it has to be off. Okay, this is from 0 to 2000, right? And this is for greater than 3000. If it is greater than 3000, this has to be turned on. This red LED. Why this is not working? Getting an ADC value. Sensor while of one. So
Sir, ADC value initialized to 0, then we'll check.
which one?
But in private variable, we are initialized, right? So we can make it equal to 0. U into 32 ADC value equal to 0.
This one,
and
this
then,
one, this one.
Yeah.
Anyhow, once you get the value here in this ADC, that will be changed, right? Even it is 0 or something, whatever it is, you are getting a value here. Or I will just do one thing. We will check whether it is going inside this one. So I'll just connect.
This resistance value need to adjust or?
That is fine. This is 1 kilo. It is actually turning on, right? This one.
Oh, really?
It has to turn off. The turn off condition is not working. That's the issue, not the turning on. Okay, I'll just connect in one more LED, or I'll just connect to the same thing. Let's say this PB1. That is PB1. Okay. I'll put it here. Let's check. We are getting some values. And the simple code is taking too much of time. Okay. So we are not actually getting the continuous value from the ADC. That is the issue. But anyhow, okay, I'll do one thing. I'll just change this PB0, this pin, I don't know. I'll just connect it to PB14. Okay. So here I'll change it as 14. Here I'll change it as 14. Here I will change it as 14. And also in the GPIO configuration, where it is. Yeah, so this is pin number 14. And here also it is pin number 14. Okay. So now I will just do this connection. Now you can see this is actually turning on. Okay, that it is actually the pin number. So this PB, we don't have PB1 here. We have something called as in PB0.1. So that is the problem. Again, another problem is this is not actually continuously conversion. Okay, even though I have enabled the continuous conversion mode here, it is not actually working. You can see I'm just making this as an low value. And if I reset, you can see this is turning on. Okay. If I move this to somewhere around here, if I run this, both this LED is off because it is somewhere around 2000 to 3000. So if it is greater than 3000, now you can see this LED is turning on. Okay. So this continuous conversion mode is not actually working here with this workpiece simulator, I think so. So probably that is the issue. We are stopping it and starting it again, but this is not working. Okay. So this is the code. Like we can set it, and whenever you are running this, it will turn on. Okay. If you set a minimum value and reset, this is okay. 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 Yeah. So those who are using Workvi, just copy this code, this circuit, and try it. Okay. So after this, we will see how to do the same ADC with an interrupt mode and DMA mode. Yeah, finish it first. Yeah, have I finished? Shall we go to next program?
Okay, sir.
Okay. So those who are working with workfree, are we done? Okay. So next, what we are going to do is we are just going to do the same thing with an interrupt mode and DMA mode. Okay. So I'm just going to create a new project. So board selector, I'm just going to select the same board. Okay. So this I'm going to name it as something like an ADC underscore hardware underscore interrupt. Okay, I'm just going to make it as an IT. IT is an interrupt. So finish. It will open an IOC file. So the only change I need to do here is in the IOC file. Okay, IOC, I need to start or I need to enable this ADC in an interrupt mode. So that is the one thing. And here in program, whenever we are starting the ADC, we need to start the ADC in the interrupt mode. That's it. Only two changes. Okay. So first change, system core RCC. I'm just going to make this bypass and this one as crystal ceramic. Okay. That is done. Next is analog ADC. This interrupt. Okay. Format is an input number 1. So I'm just going to make it as an single-ended input 1. Okay. So this is my PA0. So as usual in the configuration, what I need to do, I'm just going to make sure this is a 12-bit resolution. That is step number 1. After that, enabling this continuous conversion mode. Okay. And then, okay. There is something called as an NVIC settings over here. Okay. So this is a nested vector interrupt controller. So we have seen this, what this nested vector interrupt control in the first class itself. Okay, so I'm just going to select this nested vector interrupt control. It is asking ADC1 and ADC interrupt. Okay, so I need to enable this one. I'm going to use this ADC in an interrupt mode. Okay, so I'm just enabling this. That's it. Okay, so parameter settings, this one enable and this is 12-bit. NVIC settings, make sure this is enabled. Okay, so that's it. And here, if you go to this NVIC, you can find this ADC over here. Okay, if you want to set an priority for that ADC, you can set it over here. Okay, as I already said, NVIC, we can able to set multiple priorities for each and every devices, right? So if you want, you can actually able to set this priority over here, or 0 is the highest priority. Okay, you can leave it as it is if you want. Or if you're using in multiple modes or multiple inputs, then you can give some inputs and priorities over here. This is an preemption priority and this is a priority. Okay. Yeah, so that's it. Once again, I'll tell, go to analog ADC1, enable this input number 1. Okay, in some boards, it will be input number 0. Enable that and go to parameter settings and set as it is as like what we did in the previous example. Go to NVIC settings and enable them. That's it. Okay, so I'm just going to save. Yes. Okay. Once again, this clock issue. I'll just go to this clock configuration and resolve this clock. Okay. So generate. Yes. Yes. So it will automatically generate the code. Okay. Now you can see again the same thing, same handler, HADC1. And here also this ADC1 input. You can see this is my ADC1 instance, and I'm just enabling the continuous conversion mode. This is a 12-bit ADC resolution. Okay. So everything else is same as like what we did in the program. Okay. Now, what I'm going to do here is I'm just going to create a variable. I'll just maximize this. Okay. I'm just going to create a variable as like our previous example where it is, yeah, this one. It is an uint 32 underscore e. Okay. So I'm just going to give something like an ADC value. Make sure it is in 0 initially. Okay. Okay, so this is the first step. Second step, here inside this user code begin 3, I'm just going to write. Okay, so what we did in the previous program, we started this interrupt. Okay, we wait for this conversion and we get the value and then we have stopped this, right? Now what will happen is, actually this is, okay, I'll tell. Now what is happening here inside this while of one is we are waiting for 100 milliseconds in this particular line. Okay, this line number 5, we are waiting for 100 milliseconds for this ADC value to be converted. Okay, during this 100 milliseconds, if there is any other high priority task comes, okay, your CPU will not attend that because it is still stuck with this line number 105. Okay, it will not go to this next line until this is an, since it is an polling method. Okay, polling method is nothing but it is a line by line execution. Okay, so it will wait for that conversion to be happen and then it will go to the next line and it will just check all these things. Okay, so this is the problem here, right? So it will be an what to say, a line by line execution. This code will be executing line by line. Now here what will happen, instead of this while of one, here inside this while of one you can give any code, whatever you want. Okay, so what we are going to, we are going to write the code in this user code begin 2 that is outside of while of one. Okay, since it is an interrupt mode, your regular program can run this while of one. Okay, if there is any interrupt occurs, okay, then it will attend it and it will just check what is a subroutine written for that. It will execute and it will again come back to this while of one. Okay, so that is what an interrupt is, right? So we are just leaving this while of one as of now blank. Okay, we are not going to write anything. If you want, you can write any other program inside this while of one that will be executing parallelly. Okay, or it will execute separately without this interrupt. That means, let's say I didn't change this potentiometer value. That means I'm not getting any input from the ADC, right? Okay. Here what will happen in this polling method, even though if I'm not getting any value for the ADC, it will wait for 100 milliseconds for each and every time. Okay, but here it will only check whenever there is a change in value in the ADC. That means whenever I trigger the ADC, okay, that is as an interrupt mode, then it will go to this interrupt trigger and then it will execute. Meanwhile, other times what will happen, it will execute whatever you are written inside this while of one. Okay, so that is the difference between interrupt mode and the normal mode. So now in interrupt mode, what I'm going to do, I'm just going to simply start this ADC. That's it. Okay, so I'm just going to give al underscore ADC underscore start. So you can see yesterday we give this start, right? Today we are just going to start this in the interrupt mode. Okay, so I'm just going to click this. This is HADC. That's it. Okay, I'll start interrupt mode in HADC. So it will start this ADC and it will wait for the change in value in ADC. Until that, this ADC will not be triggered or called. Okay, it will simply execute this while of one program. But whenever you have changed any value in that ADC, then your interrupt is triggered, right? So it will just go to, there is something called as an subroutine program, a subroutine function, right? So we need to write the subroutine function. So just scroll down. This is your user code 3, right? So just scroll down to user code 4. Where it is? Yeah, here. Okay, this is your user code 4. Here we are going to write the subroutine function. Subroutine function is void. This is an inbuilt function. Okay, ADC underscore conversion incomplete callback. Okay. So this is an function. Okay. So once we are triggered an interrupt in this ADC, it will directly call this function. Okay. This callback function. So this is al ADC conversion completed callback. Inside this, I'm just going to give an ADC handle type. I'm just going to give something, some other name, whatever the name you want. I'm just going to give HADC. Okay, you can give any name over here. I'm just giving HADC. Okay. Now, if this HADC, this name, whatever the name you are giving over here, HADC, okay, in instance is double equal to the ADC1. Okay, so this is what your ADC1. So since I'm using ADC1 over here, if there is any instance occur, that means if I triggered, okay, in peak programming for the interrupt mode, you might have seen that. What is the first thing you will do? If you go to this interrupt function, you will check the interrupt flag, right? Okay, you will check the interrupt flag, whether this interrupt flag is enabled or not. Okay, that you will check. Similarly, here inside this callback function, we are checking is there any instance occur, that is any interrupt instance occur in this ADC1. Okay, if there is anything occurs, then get the value. Okay, so here I'm just going to give ADC underscore value equal to hal underscore ADC underscore get value. Okay, from this HADC1. Okay, so I'll just explain once again. Here we are starting this interrupt mode, right? So it will continuously executing whatever in this while of one. If there is any input changes in this ADC, this will call this callback function. Okay. So this callback function will be over here. Yeah, here inside this, it is checking if there is any instance, any interrupt instance occur in this ADC1. If there is anything, it will just get that value. Okay, so once it is done, what we are going to do is we are just going to start this again for this al underscore ADC underscore start interrupt for this HADC. Okay, so why we are doing this is we are restarting the ADC. Okay, in interrupt mode. Okay, so that is for the next interrupt. So restarting the ADC for next interrupt. It is like, okay, just compare the same program with your peak microcontroller. Whenever you are going inside,
this is like a interrupt handler to like
yes,
like interrupt handler. It will get this interrupt and it will perform. Then it will go to the normal.
Yes, same thing.
Same like a CPA.
Yeah. So anything inside this while of one, that is your normal program. Okay, and this conversion is your subroutine program. Interrupt subroutine program. Okay, so whenever there is any interrupt occurs, it will come over here, it will execute, and
So-
it will again go back to the while of.
For this only we given high priority. I mean, interrupt as a high priority.
Yeah, interrupt as an
Is
high
the
priority. Yes. Okay. Clear? Okay. So I'm just going to build this code and I will check if there is any error. Okay, so there is 0 error and warnings. Okay, so now I'm just going to connect my board. Okay, so I've connected my board. So this interrupt mode, I'm just going to debug. Okay. Switch. Okay. So we are in the debug mode, right? So I'm just directly going to this live expression. Since I already given this ADC value for yesterday's program, it is over there. Okay, if you are giving some other new value or new variable name for this, just give this as it is. Okay, so now I'm just going to click a resume. And if there is any change occurs, you can see my value will be happening here. Okay, in the interrupt mode. Okay, so this is for we didn't write anything inside this while of one. As you can see, this is purely happening with the interrupt. Okay, so whenever I change anything, okay, then this interrupt is triggering. It will directly go to this callback function and it will check the instance value and it will just get that value and store it in the ADC value. Okay, so that is what happening inside this interrupt mode. Here you can see there is no delay occurs. I didn't give any delay for any poll for conversions or anything to happen. Okay, so this interrupt will happen instantly without any delays. That means it will not halt your CPU for any task. Okay, so that is what an interrupt is. Okay, clear? Any doubts? If anyone wants just to
So
explain
that
it again,
setting
just
part only. Yeah,
it's
setting part.
okay.
ADC
Yeah,
hardware IT.
yeah,
That
okay,
is
okay, I'll
only.
explain. Okay, so just go to this IOC ADC1. Okay, and this input, and then in configuration there is this continuous conversion is enabled, and then in NVIC settings enable this NVIC. That's it.
Okay. So, which mean here only we are setting as a priority as a 0.
Yeah, no, here actually you can able to set this priority.
Okay, this is what I asked. Okay.
Mm.
So here we need to modify this also. NBIC also we need to modify. Or else.
No, not needed. If you want to change the preemption, then you can go for this NVIC.
Okay.
Okay. So this is the program. Finish it and tell me. Those who are using the workview simulator, do the same thing for the particular board. Okay, only copy this main.c file and paste it over here. Okay, with the same pin configuration and all these things. Only change this ADC as an interrupt. Okay, and then just copy and paste the code. That's it.
Hello, sir.
Yes, Yuvraj.
Can you please explain that interrupt part?
This one.
Yes. In that all ADC con CPL callback is there,
Okay.
right? So that
this
is
is your callback function. Okay, I'll just open this one. You can see this is what your callback function for the conversion, interrupt conversion. Okay.
this will be the inbuilt, right?
Yeah, this is an inbuilt one.
So when I'm trying to auto type that one, that is control tab, it is not coming.
It is not coming out. It won't come for that one. Since it is a function, only this what to say, your variables, your data types, all these things will be comes in the auto completion. Okay, this will not come. This you have to copy and paste it or just type it. Okay. So if you want to find this, you can go to this core folder. Okay. Inside this core folder, there is an inc include, and you can see this. There is an interrupt one. Okay. You can go over there. That is one method, and the other method is here we have include HAL driver. Is there any HAL underscore ADC? This. Yeah, this one only. Okay, we don't have this. Okay, you can go to this INT. Here you will find this is not. Okay, it is present inside this include folder, which we couldn't able to open. Here it is. Okay, you can go to this drivers folder. Okay, in that same project drivers folder, there is something called as STM32 HAL drivers. In that, check for HAL underscore ADC .h. Okay, if you open this, you will get this file. Okay, and if you just type the conversion complete callback, you will get this function. Okay, you will get all the functions over here, like what are the things, what are the APIs we are using, like ADC start. Okay, start in interrupt mode. All these things will be defined inside this HAL ADC. Okay, you can open this and refer if you want inside this drivers folder.
Okay, and if HADC instance means?
Okay, instance means this
Something?
is like your flag kind of thing. Okay, if there is any like what to say. Okay, if there is any interrupt occurs, okay, then this flag will be raised. Okay, as like your interrupt flag in PIC microcontroller you have seen, right? For a software flag. So whenever there is any software timer completion happens, then the flag will be raised, right? Similarly, this will be an instance. So if this ADC instance is happening in this ADC1, okay, then get the value. As if this flag is raised, then get this value. So it's something like that.
So it is like a software interrupt.
Yeah. No, everything is software interrupt. Here we didn't give any hardware, right?
That's what. Nothing we are giving, directly it will trigger.
Can you show the code, sir? Okay.
Yeah. This part or the main function. On top of main function, you just have to start this HAL underscore ADC underscore start underscore IT. That's it.
Sir,
Yes, Yuvraj.
actually, I have tried with the two different voltages, but the value is coming the constant 4095 only.
For both 3.3 as well as 5.
Yes.
Okay. Okay, just a minute, guys. I'm going to stop share this. Yeah, can you share the code? I mean, share the screen.
Yeah.
Yes. Yeah. Okay. Okay. Yeah. Go to debug mode.
It is 3.3.
Okay.
It is 5.
Okay. Give 3.3. Okay. 1090 something. 95.
Equivalent binary will come.
Is there any other voltages? No. Right. We have
Actually, I
only
am connecting
3.3.
through. Yes, using board only.
If you have any resistor with you, do you have any resistor with you right now? Just connect across the resistor with this 5 voltage. You will get a drop down voltage, right? And then give that another pin to the ADC, A0. If you have a resistor with you. Here, actually it is changing because when you remove that voltage, it is changing to 0. So there is a change in voltage, but it is not showing accurately for this one.
No, don't have the resistor.
You don't have resistors. Okay.
For others also, it's coming the same.
Yeah, yesterday for me it is coming somewhere around 4060 something for 3.3 voltage.
And then maybe
Yeah.
that is the correct.
Maybe it is taking that as a reference voltage, probably.
Okay. Okay, fine.
Yes, okay. Okay, so others, have we finished? Shall I go to the next
1
one?
minute, sir. 1
okay.
minute.
Okay.
Please show it that code only. That
Yeah,
maybe I mistake
Just
something. We'll handle it. Sir, interrupt the 4 lines for missing water. மேல இருக்காங்க.
புரியல.
கோட் வந்து இந்த 4 lines மட்டுமா இல்ல மேல ஏதாச்சும்?
மேல இந்த
Starting
ஸ்டார்ட் கொடுக்கணும். ஸ்டார்ட் இன் இன்டரப்ட் மோட். இது.
Okay, sir.
Okay. So first you have to start the ADC, then the conversion will happen.
Sir, one doubt, sir.
Yes, Arvind.
Hello.
Yeah.
Yes. So that in interrupt function, interrupt handler function, so we have HADC, right? So that value also is similar, same as the HTAC one only.
Which one?
That input.
This one.
HADC.
This can be anything. No, what this handler name is HADC1. Okay. And here I have given HADC. It can be anything. This name can be anything. Okay, this is user defined
Then
value.
here we can get the value HTAC also possible. It is not.
But it should not be HADC1 since it is already declared as an handle.
Okay.
Okay, so apart from HADC1, you can give any name.
Okay. So that HDAC one and this variable is different.
Yes, these two are different. Okay. Here you can give something like 1 and here also 1. Okay, this is possible. You'll get this value. Okay, so this is an user defined value. It can be anything. Clear? Okay, shall we go to the next one?
Yes, sir. Yes, sir.
Yes, okay. So the next one is our DMA. Okay, so DMA, as I already said, it is an direct memory access. So instead of using your CPU, your DMA controller will handle all this conversion. Okay, this ADC value transfer to the variable. Okay, so that is possible. Variable is nothing but it is present in the memory, right? Your memory. Okay, your ADC is nothing but it is a peripheral device. So a peripheral has to transfer the value to memory. Okay, so there is a communication between peripheral and memory only. The CPU is not needed there, right? For this data transmission. Okay, so it need not to be transferred via CPU. Okay, so now what will happen here? This DMA will actually taking care of this conversion from this peripheral to this memory. Okay, so that will be done by your DMA itself. So that we are going to see how to do that. So ADC hardware DMA. Yeah, so here again the same system core. I'm going to this RCC, this bypass, and this one crystal ceramic. Okay, so first this clock configuration is done, and here this multiplier I'll make it 4 for this ADC configuration. Okay, now here in this analog, again the same thing, ADC1. This is input number 1. I'm just going to make it as a single indent. That is PA0. Okay, so now in this parameter settings, again the same thing, make sure it is a 12-bit resolution and then continuous conversion mode enable. Okay, so last time for an interrupt, what we did for this NVIC settings. Okay, and we enable this interrupt. Similarly, now what we are going to do is go to this DMA settings. Okay, so this part in this ADC, select the input and change the parameter settings and then open this DMA settings. In DMA settings, click add. Okay, I'll just maximize this one. Click add. It will tell you which DMA request has to be called here. Okay, so now I'm going to do this for the ADC1, right? So select this ADC1 and here all these things will happen. Okay, whether it is a normal mode or a circular mode. Normal mode means it will be conversion from, from this peripheral to this memory. That's it. Okay. Circular mode means after this, like, what to say, the value will be in the circular, like from peripheral to memory, memory to peripheral. So that DMA request will be in the cycle. Okay, so that is what this mode, normal or a circular mode. Okay, so this we will select it as, okay, I'll select this as in circular mode. I think it's normal mode. Okay, so we can select as a normal itself. Okay, we'll see the difference, what is happening. And here the direction is peripheral to memory. Since this is an ADC, ADC is a peripheral device and it is going to transfer the data to the memory. Okay, so this is peripheral to memory direction, and DMA channel is channel number 1, and the priority is whether it has a low priority or medium priority, high priority or very high priority. That we can able to select it over here. Okay, and so data width is offered since it is an 16-bit. Okay, so word length is nothing but it is a 32-bit. Okay, half word is a 16-bit, and the byte, it is an 8-bit. Okay, since ADC is a 10-bit ADC here, half word is more than enough to transfer the data. Okay, so I'm just selecting it as an half mode for both the peripheral as well as the memory. Okay, so that's it. So this is for the configuration you need to set. First one, ADC input, single ended input. Okay, and then parameter selection. Make sure all the parameter selection as like your previous example. And then go to DMA setting, click add, and then select the ADC, which ADC you need for a DMA request, and then select the direction, and then make sure it is in a mode, normal mode or a circular mode, and then data width. That's it. Okay, so click Ctrl S, it will generate the code. Okay, so now without the CPU intervention, we are just going to transfer the data. Okay, so that we are going to do right now. For that, again, I'll just maximize this. In this private variable, I'm just going to, okay, here inside this private variable, it is somewhat different from your regular, what to say, your interrupt mode or a polling method. Okay, the difference here is uint 32_t. Okay, here your value will be transferred to, there is something called as a DMA buffer. Okay, so this DMA buffer will actually take that value and it will send that value to this peripheral one by one. Okay, so that is what it is going to do. Okay, so I'm just going to type this ADC buffer with an array value of 1. Okay, I'm just going to transfer only one value over here. So that is an ADC buffer of 1. Okay, so it has to be in the array. If it has multiple channels, depends on the number of channels, you can change this array number. Okay. Right. So instead of a regular variable, I'm just giving it as an array variable. Okay, so that is the first changes you need to do. And the second one is, this is as like the same thing. Okay, we are not going to disturb the while of while of 1 because your CPU will not be disturbed in this data transmission, right? Only this DMA controller will take in all this data transmission. Okay, so now here also I'm just going to write it on the top of this while of 1, HAL underscore ADC underscore start in the DMA mode. So this is my DMA mode. Okay. Okay. Now, whenever you are starting this in the DMA mode, it is going to ask which ADC handler I need to transfer, what is the data, and what is the length. Okay. So here HADC And the data buffer is nothing but this ADC buffer. That is where I'm going to transfer. And the length is I'm just going to transfer one value. Okay, so that is what the length is. Okay, so Al underscore ADC underscore start DMA. I'm going to start this ADC in the DMA mode for HADC1. That is same handler for ADC. The buffer I'm going to transfer is ADC buffer, and the amount of value I'm going to transfer is one value. That's it. Okay. So this is for starting the ADC in the DMA. And similarly, like your interrupt mode, here we are going to call a callback function. Okay, so that callback function is same thing, void space hal underscore ADC underscore conversion complete callback. Okay, so once you type this, just make sure hold your control button and click it and make sure you're checking that it is properly written. Okay, so this is a completion complete callback. Okay, inside this I'm just going to give the same inside this I'm just going to give the same ADC underscore handle type def. Okay, this is HADC. You can give anything here as like our previous program. I'm just giving it as an HADC. Okay. Okay. Here, what we are going to do, if this HADC, this instance, okay, is double equal to ADC1. Okay. Leave it as it is. Okay. Okay, so here we are not going to do anything. We will leave it as it is. So if you want to perform any particular operation, like whenever each and every time, if you are getting a value or after completion of that value, if you want to notify something like an LED turn on or anything, you can just give it over here, or else you can just leave it blank. Your buffer value will be automatically transferred via this DMA. Okay, so there is no need to do anything. So this part will be handled by your ADC. Okay, so there will be no CPU intervention will happen in this data transmission. Okay, even in your interrupt mode, whenever you give interrupt, your CPU will go there, go to the subroutine and it will check all this instance and transfer. But in DMA mode, your CPU will not come into picture. Okay, only your DMA controller will take care of all these things. Okay, so that is the advantage of using the DMA here. You will not what to say. You will not strain your CPU for data transmission, simple data transmission. Okay, if you want to check anything like this ADC value as something like an if it is greater than some value or less than some value, as like what we did in workfee, there we required an CPU. Okay, for a simple data transmission, the CPU is not needed. This ADC can directly transfer the data to this memory, right? Okay, why we need a CPU for that? Okay, so in that condition, we can use this as a DMA. Okay. Is the code clear? Just a minute.
So in order to avoid the CPU usages, we are using.
Yeah. So meanwhile, CPU can perform some other operation also. Inside this while of one, you can give any code. Okay. And your CPU can perform this code. Okay. It will not affect this DMA performance. This data transfer will happen separately. Okay.
So what will be the maximum size for the buffer?
The buffer maximum size is, okay, what is the value you are going to transfer? 0 to 4095, right?
Yeah.
Okay, so the 4095 is nothing but it's a 12-bit, correct? So that is a
Yeah.
buffer size here.
Okay. So if we are using the multiple inputs also, the same buffer will be using, or we need to
Actually,
give
here the
different
buffer
buffer.
is declared as an uint32_t. So that is what the buffer size. If you're using multiple channels, for example, if you're using 2 channels, then give 2. Okay, so it will be 32-bit for one channel, 32-bit for another channel. Okay.
Yes, sir.
Yeah. Okay, why we didn't give here anything like something like an ADC underscore value equal to last time we did write something like an null get value.
Get value.
Okay, why we didn't give here is we want to check this ADC value. Okay, so for that we are actually getting this. But here what is happening? This buffer itself is getting some values from your DMA directly. Okay, this buffer, your DMA value will be transferred to this buffer itself. So we can check this buffer for the what is the value present inside this ADC that can be seen in this buffer itself. So there is no need to use another variable for getting that value. Okay, anyhow, this buffer is going to store the ADC value, right? So we can able to check that itself directly. So that's why we didn't use it. If you want, you can give some like LED turn on, something like that. Okay. Once this instance has been completed, then you can blink this LED, toggle this LED, something like that you can able to get if you want. Okay, or else just leave it as it is. So I'm just going to build this code and check if there is any error. No, there is no errors. Okay, so I'm just going to debug this. Okay. Switch. Okay, so this time this ADC value is not present inside my code. Okay, so I'm just going to remove this and I'm just going to use this ADC buffer. Okay, so once you give this ADC buffer, you can see the type, the value that will present. If you open, you will get the value. Okay, since it is an array, you will get this one. Okay, so if I give run, you can see now this value will present over here. This one I need to change for. Okay. So this is my value. Okay. Now, even if I change my potentiometer value, this value will not get updated. Okay. Because I have given this DMA in the normal mode. It's not in a circular mode. Okay. So that means it will only transfer the data once and it will stop. Okay. So that is what a normal mode. Now I'm just going to change this as a circular mode and I'll generate the code. Okay, everything else is same. We are not going to change anything. Only this is circular mode. That's it. Make sure your code is present over here. Yeah, this. Okay, I'm just going to build this. And I'll just debug this one. Switch. This buffer value is not updating. Continuous conversion.
Sir, other than initialization, we are not using that buffer value anywhere in the interrupt, sir.
No. So buffer value, we will not use that buffer value. Okay. What this buffer means? Your DMA will store that value temporarily in buffer. From that buffer, this value will be transferred to that particular memory. Okay, that is what this buffer is for.
Okay, but there is no any relationship between the DMA or that buffer in anything. Oh, okay, okay. Oh,
Here we are
okay.
giving this ADC buffer.
Oh, okay.
Yeah. Okay. Okay, so try this one. Okay, this buffer. Continuous mode. This is my ADC buffer of 0, right? Okay. That is my 0 value. Okay, so here what will this buffer happening is, this buffer actually stores our recent value. Okay, it is not actually taking the value. It is only taking the recent value because your DMA is actually transferring this value to the memory, right? So only this recent value will be updated. So what we will do is I'm just going to give you int 32 underscore p. I'm just giving something like a latest underscore val equal to 0. So let's put something like an latest underscore val equal to ADC buffer of 0. So each and every time we are changing this value, that latest value has to be updated. Let's check whether we are getting this. This is for debugging purpose only. Okay, we need to display this value. That's why I'm giving. If you really want to transfer the data to peripheral from this memory, this variable is not needed. Okay, you can directly transfer the data. That is the thing. What is the value I've given? Latest underscore val, right? Okay. So let's say I'm just giving this. Started this DMA. Still it is not showing. Why? Why? Mm. Okay, so I think DMA will only show the value of your current updated value. It will not show the live value. So each and every time whenever you are running, that particular instant value has to be transferred. That's what DM is doing. Even the given it is circular mode, it is not working. Make sure it has an word length of high priority. Okay, so build this and switch. Okay, for you people, are you getting the same kind of output or something like a different? The value is not updating. So the latest value, whatever it is, the recent value which is updated, that is what printing here for me. Okay, is the same for you? Or are we still have to type this code? Just leaving this one. Okay, try this one and tell me whether you're getting an updated value or only the last instant value. Is it clear what is happening in this DMA? Or is it confusing? Something like that. Guys, is it clear?
Yes, sir.
Okay. Yeah, try this one. On top of that while of one, just give al underscore adc underscore start underscore DMA. That's it. Okay. This is your conversion.
ஒரு வேல்யூ தான் சார் இருக்கு.
அந்த லேட்டஸ்ட் வேல்யூ என்னவோ அது மட்டும் தான் அப்டேட் ஆகுது. So okay, so tomorrow we will see the timer. Okay, so how to use the timer here, and timer itself will be having a multiple modes. How to generate a time delay, how to create a PWM signal, okay, how to get an input capture. Okay, all these things we will see tomorrow. Okay, yeah. So these recordings are available in that same link, which is shared on that first second day, I think so. Okay, so all these recordings are I'm just regularly updating there. Okay, you can check it over there. Okay, so thank you and bye. We'll see tomorrow.
Thank you, sir.
Thank you. Bye.
Hello, sir. 1 second.
Yes.
One doubt only. I just share my screen.
Yes, sir.
So in the DMA controller, I can see the DMA 2 stream 0 only. It's the 0 and 2 4.
Okay.
Yeah, then I mentioned normal. So yeah, later we can change it as a circular only. But
Circular,
yeah,
yes.
this
one you are having different stream.
Yeah,
Okay.
I have a different. That's what. And here for the increment address peripheral, we should not click it now, sir. Memory is or default is
Memory.
click it.
Yeah, we need to check memory only. Because we are going to store only in memory, right? Not in the peripheral.
Memory only.
Yeah.
Okay, sir. That's it.
Yeah, that's it.
Sir,
Yes, Yuvraj.
so இப்போ ADC buffer 1 and போட்டா வேல்யூ மாறிட்டே போகுது சார், இன்க்ரிமெண்ட் ஆயிட்டே போகுது.
1 and போட்டாவா?
buffer of 1 போட்டா
Buffer of 1ல எதுவுமே இருக்காது ஆனா.
இது ரேண்டம் வேல்யூ இருக்காதா? ஏன்னா இன்க்ரிமெண்ட் ஆயிட்டே போயிட்டு.
என்ன செக் பண்ணி பார்க்குறேன். என்கிட்ட பொட்டன்ஷியோமீட்டர் இருக்குல்ல, நான் செக் பண்ணி பார்க்குறேன்.
ஓகே சார்.
ADC buffer of 1.
சார், அங்க இதுலயும் ஸ்டார்ட் டிஎம்ஏலயும் அதே மாதிரியே போட்டிருக்கேன். ADC buffer of 1.
ஸ்டார்ட் டிஎம்ஏல ADC buffer of 1 தான் கொடுத்துருக்கீங்களா? அப்படி கொடுக்கக்கூடாது.
ஓகே.
Okay, wait, I will check. ADC. அது கண்டினியூஸா ரன் ஆயிட்டே இருக்கு ஏதோ வேல்யூ. ஸ்கிரீன் ஷேர் பண்ணலையா? நான் ஷேர் பண்றேன். தெரியுதா? So ADC buffer of 1 is constantly running.
அப்படிதான் ஆயிட்டு.
So this is wrong.
ஓகே.
இதுதான் நம்மளோட ஆக்சுவல் வேல்யூ.
ஓகே சார்.
Okay, I'll see you tomorrow.
Thank you, sir.
Bye.
Yes.
Yeah, thank you. Bye.